Hello students, welcome back. We are in the final phase of the set theory. In this video, we are going to solve the miscellaneous exercise problems. See, plenty of the questions will be asked in the examinations are from this exercise. Okay, so we'll understand thoroughly concepts and solve the problems. So in this, what is A set equals to? The solution set of this equation x square minus 8x plus 12 equals to 0. This is x minus 6 into x minus 2. This is so equals to 0. So x equals to 2 or 6. So this is the solution set. A is 2 comma 6. What is B? B is 2 4 6 and C is 2 4 6 8 and all the even numbers. D is only 6. Which sets are subsets of one and another? You can see first A is this. Definitely A is a subset of B. Also A is subset of C. But D is only a single element. It's not a subset. But D is subset of A. D is subset of B. D is subset of C. Right? And also B is subset of C. B is subset of C. So we can write A. D is subset of A. E is subset of B. E is subset of C. Right? And B is subset of C, A is subset of B, also A is subset of C. Okay, this is pretty simple. So this is the solution. A is such that x belongs to R and satisfies this equation. We found out the solution set as 2, comma 6 and B is, these are the sets. From here directly you can deduce D is a subset of A, is a subset of B, is a subset of C. So A is a subset of B, A is a subset of C, and B is a subset of C. D is a subset of A and B and C. This is what we have written. In nutshell, this is the answer. So we'll move to the next question. In each of the following, determine whether the statement is true or false. If it is true, prove it, else it is false. Give an example. So now we'll take a set A such that you have got two elements 0, 1. And we'll take another set B so that 0, that A is included in that. A belongs to, you can see A belongs to B. So 0, comma 1 is an element. It's not a set. This is the set is as an element it is present there. And 2. This is B. Let an arbitrary element x is equal to 1. X belongs to A. Yes, true. Right? But X belongs to, that's what you wanted to say. When X belongs to A, is it true or not? X belongs to B? So, see, 1 is there anywhere in this? Yeah, it's not there. 1 is there inside the set. It is not an element. The set itself is an element. So, there is no element in B. X does not belong to B. So, this is false statement. Next one is what? A is a subset of B, right? And B belongs to C. That means let A is equal to 1 comma 2. This is one set. And B is 1 comma 2 comma 3. Right? So definitely A is a subset of B because all the elements of A are present in B. Now we write C. What is C? C is B belongs to C. That means we can write 0 that B is there inside. Okay, this is present in this and some more elements. This is C. So what is asking is A belongs to C. A is what? 1, 2. Can you see 1, 2 is there here? No. A. So A does not belong to C. The statement is false. I want to tell you one thing. Here, if C is having elements 1 and 2 also here, in that case, A also belong to C. In that case, when these are there, these elements are there. But if they are not there, this is cannot be true. This is not. Sometimes it is true, it is true. Sometimes it is false. It is sometimes it is false. It is sometimes false. So we cannot guarantee say that in that case we'll say it is the statement for sure you cannot say true. So that is false. So this is the solution. And for the second one, I accommodate, I have to erase these things. So this is the solution I have written here. We'll move to the next question. Next, the third one. If A is subset of B and B is subset of C, then we have to prove that A is a subset of C. Is asking A is subset of C or not. So A is a subset of, suppose C. It is pretty straightforward. What is given? A is subset of B and B is subset of C. So let an element X belongs to A. That implies that X belongs to X also belongs to B. That implies X also belongs to C. Right? Then naturally, because X belongs to A and X belongs to C, A is a subset of C. This is true. We can just suppose we can take an example and prove it. A is equal to 1 comma 2 and B is equal to 1 comma 2 comma 3. So A is a subset of B. So C is equal to, this is C. B is a subset of C because 1, 2, 3 also contained in C. So naturally 1, 2 is a subset of C. A is a subset of C. Clearly A is subset of C. This is the statement is true. We'll move to the next one. Next we'll see the fourth one. If A is not a subset of B and B is not a subset of C, then E is not subset of C. This is what the statement says. We have to either prove it or disprove it. Given is A is not a subset of B and B is not a subset of C. Let us take some examples. Let A is equal to 1 comma 2. B is having elements 0, 1, 4, 8. C is 0, 1, 2, 9. Now clearly A is not a subset of B. Clearly A is not a subset of B. Correct? And B is not a subset of C. But A is a subset of C. Correct? Thus the statement given is wrong. Here, as I explained in the previous question, that sometimes it may be a subset of A and C, but it is not always. So the statement is a always A is not a subset of C. That is false. It cannot be always true. Suppose C equals to, let C be a set of containing 0, 2, 3, 9 as elements. See, clearly A is not a subset of C. And also it satisfies the condition B is not a subset of C. This statement is correct in this case. So then A is not a subset to C. Statement is sometimes it is true, sometimes it is not true. So it is not always true. So then in that case we'll say statement is false. We'll move to the next question. In this question, if X belongs to A and A is not a subset of B, then X belongs to B. Verify the statement. So we'll take an example. Let A equals to this 0, 1. B is 1, 2, 3, and we'll take an arbitrary element x is equal to 0. X belongs to C. Then x belongs to here. Clearly, A is not a subset of B. Correct? Clearly, A's elements are not present in B. So, A is not a subset of B. X belongs to A. Correct. True. Because 0 is there. 0 is also present here. That means even if x belongs to A is not a subset of B. X belongs to B is not guaranteed. This statement is not true always. This is false. Suppose B equals to 0, 2, 3. In that case, A is not a subset of B, but X belongs to B. This X is there in the B set also. This statement is not always, this statement becomes true here. So sometimes it is true, sometimes it is not true. In that case, we'll say that the statement is false. Okay, the same logic I told you in the previous question also. This is false. This is x is equal to 0, not it becomes a set. So this is if x, this is in written I have given this, given is x belongs to A does not belong to B. We have taken the same examples and x is equal to 1. We have given here A is not a subset of B, but x belongs to B. So the statement is false. Okay. Now the next example. If A is a subset of B and x does not belong to B, then x does not belong to A. Let us take an example. Let A is equal to 1, 2 and B equals to, because A is a subset of B, all the elements of A will be in B also. So 1 and 2 are there, here also there. So first statement is valid. First statement is, it is, so what, let us say x equals to does not belong to B. That means it is an element which is outside this B set. Suppose 4 is there. This x belongs to A. This 4 does not belong to A, right? 4 does not belong to A. So this is always true because the elements all which are not in B cannot be in, definitely in not, cannot be definitely cannot be in A also. So for sure we can say that this statement is true. This statement is always true. Given A is subset of B, A belongs to B and x does not belong to B. That means what? X. So I have given written the written explanation here. X does not belong to A, question mark. This is what we have to check. X does not belong to, X does belong to A. We have 4 does not belong to A. So X does not belong to A. So this statement is true always because A is a subset of B, and if the element is not present in B, it will not be definitely present in A. We'll move to the next questions. See, in this question, the three sets A, B, C, and A union B is equal to A union C, and also A intersection B is equal to A intersection C. We have to prove B is equal to C. There are multiple ways of showing this. I will first I will start with the algebraic notation. First, I will show you all the methods. This question, it will improve definitely your understanding of this set theory, how to solve different types of problems. The way the examiner asks, if it is algebraic notation, or it is Venn diagram, or it is through formulas. All the three methods I will show you. First is algebraic notation I will show you. Let x belongs to B. Then x also will belong to A union B, right? It implies x belongs to A union C, because A union B equals to A union C is given. This implies x belongs to A or x belongs to C. Correct? So we'll take the case when x belongs to A. We have started with this, right? We started with this. So x also belongs to B. Therefore, x belongs to A intersection B. It belongs to B as well as it belongs to A. Correct? Therefore, x belongs to A intersection B. That means x belongs to A intersection C, because A intersection B equals to A intersection C. Given. This is given. That means what it implies? That means x belongs to A and x belongs to C. So finally, x belongs to C. So we have observed this. We have started with here x belongs to B. We ended up with this. X belongs to C. Therefore, B is a subset of C. Agreed? Similarly, we can show C belongs to D. I'm going to show that for your understanding. It will be very clear to you. Let x belongs to C. Then x belongs to A union C. So x belongs to A union P, because the same reason A union B equals to A union C. This implies x belongs to A or x belongs to B. So similar, right? When x belongs to A, we started with x belongs to C. So what? Therefore, x belongs to both. X belongs to C and x belongs to A also. X belongs to A intersection C, right? Therefore, x belongs to A intersection B. That means what? Because A intersection B equals to A intersection C. Agreed? This implies x belongs to A and x belongs to B. Therefore, x belongs to, we'll take x belongs to B. We started with x belongs to C and we have reached x belongs to B. Therefore, C is a subset of B. So, from this, we know very well from 1 and 2, 1, B equals to C. You understand this? Will be very useful. Will be very well prepared for the competitive examinations, even not only CBSE, but JEE also will be prepared well. I'm going to give you in the next slides the other two methods. This is the first method. We will be seeing the second method in the next slide. The second method. See, given is all this data. I have repeated this. I have produced this. You remember this formula I have given in the previous videos. You can go and refer to that. A union B equals to A plus B minus A intersection B. This is the formula we are going to use. Simply substitute here. This is what? A plus B minus A intersection B equals to, second one we will take, A plus C minus A intersection C. Right? Simply you can cut this A intersection B. A intersection B equals to A intersection C. Right? So this also you can cut. So B is equal to C. In 2 steps we got the answer. But the first method what I saw is the NCERT solution answer. We are not going complete. I have given you here the complete solution there. So that is one solution. This is the second solution. This straightforward and using the formula. Third method I will give you in the next slide. Now we'll see the third method. The same thing, given data is this, A union B is equal to A union C and A intersection B equals to A intersection C. We have to show B equals to C. See, we have seen certain formulas in the previous videos. We should remember all them. We know that A equals to A union A intersection B and A equals to A intersection A union B. These two are very important. And it is simple, it is not difficult, but you should remember them. You can see this, suppose this is A, this is B. Suppose this is A, this is B. What is A union B? This is A union B. So what is A? This is, you can say A. What is intersection between A and this white portion? Is complete. Right? A intersection A union B. This A is the result. So this is how you look at this. A is equal to A union A intersection B. Also A equals to A intersection A union B. Intersection also the same thing. So we'll use these results in our proof. We'll see what is B now. B equals to B union. We are using the same formula. B union B intersection A or B union A intersection B, because both are same. Also equals to, because B intersection A intersection B is what? A intersection C. B union A intersection C. Correct? This A intersection B equals to A intersection C. Since A intersection B equals to A intersection C. Now you can distribute it. B union, tell me, while doing you should tell me. B union A intersection B union C. B union A intersection B union C. Distributive law. Equals to what? A. We are simply changing this. A union B. I'm just interchanging them. A union B equals to B union A, right? So intersection B union C equals to A union B is what? A union C. Correct? Intersection B union C. Because given A union B equals to A union C is given. This equals to, I'm just changing the order, C union A intersection C union B. This equals to, if you can see, it is distributed. U is distributed over R and U is distributed over intersection, and intersection is can be distributed over union. Remember this, I have shown you in the algebraic problem, algebraic explanation. You can refer to that as detail. In detail, I explained that. So C union A intersection B, right? C union A intersection B by distributive law, right? In fact, it is, we are reversed it, reverse of that. This equals to what? C union A intersection C. Since C union A intersection C, because it is given A intersection B equals to A intersection C. So this is what, when you observe this is nothing but similar to this, right? C union A intersection C is nothing but C. Understood? This is A union A intersection B. Any three A's are there. A union A intersection B. Any set, you will be ending up with A. B equals to C. So I have given you all the three explanations. Second one is obviously very simple, but this gives you a lot of understanding of the sets. This is formula approach. This also gives you the second one also. First one also gives you how to go about algebraic approach. I think you appreciate this. If you like this video, like, subscribe, and share with your friends and classmates. And we'll meet you in the next video with the solutions to remaining questions of the miscellaneous exercise. See you then.